Nothing happens on screen. The cursor blinks. You typed the prompt 11 seconds ago. You're still waiting. Somewhere behind that spinner, a model is thinking, and you are just sitting there, hands off the keyboard, trust draining out of you 1 second at a time. You tell yourself it's fine. It's not fine. Your brain already decided this tool is slow, and no amount of accuracy in the final answer is going to undo that first impression. Here's the problem. Nobody in this space wants to say out loud. Every week there's a new coding agent, a new copilot, a new chat interface bolted onto an IDE, and almost none of them get evaluated the way real interfaces get evaluated. We talk about context windows, we talk about benchmarks, we talk about which model writes cleaner code. Nobody talks about whether the interface itself is psychologically sound, because everybody assumes UX rules are for consumer apps, not developer tools. That assumption is costing you hours of frustration you've been quietly blaming on yourself. So here's the object. Long before AI dev tools existed, designers built a set of 19 documented psychological principles for how humans actually experience interfaces. They're called the laws of UX, and they were compiled from decades of academic research, some of it going back over a century. Here's the part nobody tells you. You can run any AI coding tool you use today through these laws like a diagnostic, and the results are not flattering. One number to sit with before we go further: 400 milliseconds. That's the exact threshold researchers set in 1982 for how fast a computer needs to respond before a human stops feeling in control of it. Most agentic coding tools blow past that number by a factor of 10 or more every single time you hit enter. Let's slow down and actually look at this. That 400 millisecond number comes from Walter Doherty and Arvind Khaira, published in an IBM Systems Journal paper. The previous industry standard for acceptable response time was 2,000 milliseconds. Doherty's research showed that once you cross under 400 milliseconds, something changes in how a person relates to the tool. It stops feeling like a program you're operating and starts feeling like an extension of your own thinking. Cross that threshold and productivity spikes. Miss it consistently, and users describe the tool as sluggish, even when it's technically working correctly. Apply that to your daily coding agent. If it takes 8 seconds to return a suggestion, you're not in flow. You're in a waiting room, and your brain treats every visit to that waiting room as evidence the tool can't be trusted. Now take Fitz's law, from a 1954 study on human motor movement. The time it takes to hit a target depends on the distance to it and the size of it. Small button, far away, more errors. Look at how many AI tools bury their most important action. Accept suggestion, dismiss suggestion, run this cell, behind a tiny icon in the corner of the screen instead of putting it right where your eyes already are. That's not a bug. That's a measurable design failure predicted by research from 1954. Then there's Hick's law, from a 1952 study by William Hick and Ray Hyman. The more choices you present, the longer it takes someone to decide. Open any modern AI coding tool's model picker. 10 options: fast model, smart model, reasoning model, cheap model, preview model. Every one of those choices adds real decision time before you've written a single line of code. The tools that let you pick a default and disappear the menu are working with the law. The ones that surface every option every time are working against it, and they don't even know it. Miller's law matters here too. George Miller's 1956 research put the average human's working memory at around 7 items, plus or minus 2. Think about how many active agents, tabs, extensions, and context windows a modern AI-assisted workflow asks you to track simultaneously. Most setups blow past 7 within the first 10 minutes of a session. That's not a discipline problem on your end. That's a hard ceiling built into human cognition, and most tooling ignores it completely. Here's the strange part. The Aesthetic-Usability Effect, documented by researchers Misaki Kurosu and Kaori Kashimura at the Hitachi Design Center in 1995, found something uncomfortable. Across 26 variations of an ATM interface, people's ratings of how easy something was to use correlated more strongly with how good it looked than with how easy it actually was. Translate that to today. A polished, well-branded coding assistant with a clean chat window gets rated as smarter and more reliable by users, even when the underlying model is identical to a competitor with a plainer interface. You are not judging the intelligence of the tool. You are judging the paint job, and you don't know it. Two more, quickly. The von Restorff effect, from Hedwig von Restorff's 1933 study, showed that when one item in a group looks different from the rest, it's the one people remember. Tools that visually highlight a single flagged error in a sea of green check marks are working with this. Tools that bury every warning in identical gray text are wasting a documented memory advantage. And the Zeigarnik effect, from Bluma Zeigarnik's research in the 1920s, found that people remember unfinished tasks far better than completed ones. Any agent that fails to clearly mark an incomplete multi-step task is throwing away a psychological hook that could keep you oriented across a long session. So here's the verdict. This gets a B. Not because the framework is weak, because the ceiling is real. The laws of UX are a genuinely useful lens for evaluating AI dev tools you already use. They expose exactly why a tool feels trustworthy or exhausting, using research that predates the entire AI coding category by decades. Where it falls short. This isn't a build guide. It won't tell you how to architect a plugin or fine-tune a model. It's a diagnostic, not a blueprint. And it doesn't account for the fact that AI tools have a variable that classic UX research never had to deal with: genuinely unpredictable output quality, not just interface friction. For who this works, developers actively choosing between competing AI tools who want a framework sharper than marketing copy and screenshots. For who it doesn't, teams looking for implementation guidance on building their own AI features from scratch. So, to recap, AI coding tools are almost never evaluated on interface psychology, only on model quality. The laws of UX give you 19 research-backed lenses to close that gap. Doherty's 400 millisecond threshold explains why slow agents feel broken even when they're accurate. Fitz's law and Hick's law explain why button placement and menu choice quietly cost you time every session. Miller's 7-item ceiling explains why juggling agents and tabs exhausts you faster than it should. The aesthetic-usability effect explains why a good-looking tool gets undeserved trust. And von Restorff and Zeigarnik explain why some tools keep you oriented during long sessions, while others let you lose your place entirely. The verdict: a solid B, sharp as a diagnostic, useless as a construction manual. Which one of your daily tools breaks the most laws here? The beautiful one that makes you wait, or the ugly one that never does? Tell me in the comments which tool you'd actually defend. No hype, just the stack. See you in the next one.